This has a dimension 10 by 1. Yeah, 10 by 1. And again, if we just want to store this vector, we write a colon, and MATLAB stores it then in the system. What else could we do instead of writing explicitly 10 by 1? If we have defined already, if we have defined capital K as 10, if we write then y should be once k comma 1, it would give us the same thing, yeah, because we have defined k as 10. What it would give us here, it would give us a vector that has ones in a column consisting of 10 entries. So it would be a 10 by 1 vector of ones. Same thing as this. So these commands here are obviously equivalent. It all depends on what we have defined before. Yeah. So let's take this away because we need some space again. So the most important thing that you will encounter, or that we will discuss in this course, that you should know after this course, is actually the so-called for loop. Yeah? The for loop. That's the most important thing that we will do here. And you will hear, yeah, for loop. And of course, some of you might have already some pre-knowledge, yeah, from computer classes and so on and so forth. And some people may argue, yes, the for loop is slowly and so on and so forth. And well, probably it is. But nowadays, you know, we have so much computer power that it doesn't matter. You know, it's so fast anyways. So people who have more background in physics or whatever, they talk about vectorizing, and that's fine. Yeah, that's perfect. And if you run simulation studies and so on and so forth, then it might make sense to vectorize things and to put as many things as you can do outside the for loop. Yeah, but for our purposes and for basic finance research, that's obviously not necessary, given we have so much computer power nowadays. So we can just translate everything from our econometrics formula into a for loop, and we can do basically all the things that we need with just basically one loop that we need to learn. So, and of course you can have one for loop, you can have many for loops, so it all depends on what you want to do. But most of the exercises that we will discuss, they will require just one for loop, right? So let's say let's define our data matrix. Let's say we have a data matrix, yeah, in our system already uploaded, and let's call it, it's capital Y. Okay, our data matrix is defined as capital Y, and what is it? So it has many different vectors, obviously. Let's say we have capital T observations. Yeah, we have here Y11, Y12, Y13 until small y capital small y1 capital T. So let's say these are the excess returns of our first stock. Then here, the second column, we have y21, y22, y23, and so on until y2 capital T. So the second column, we have the excess returns of our second stock, and we have capital T observations in our system, in our data matrix. So, and so on and so forth, until we have we end up with the let's say 10th stock. Yeah? Here's then y10 1, second element is y10 2, y10 3, and the last element would be then here y10 capital T. Yeah? So our data matrix Y has the dimension T. We have T time series observations, and we have 10 stocks in our universe, so it has a dimension capital T by 10. Yeah? That's our data matrix. In addition to that, we have, let's say we have a vector x, and x stores the excess returns of the market vector. Yeah? The excess returns of the market vector. That can be the S&P 500, for instance. So x1, x2, x3 until x capital T, which is obviously a T by 1 vector of market excess returns. So this is our data matrix. That's what we have in our system. Let's say, so a very simple application of the for loop could be, let's say we have a matrix P. We start with a matrix P. We create a matrix P that has zeros, P, capital P, equal with zeros, K, comma, 2. Okay? So, and let's define, before we define P is equal with zeros, in parentheses, capital K, comma 2, we say, okay, K defines the dimension of our stocks, which is 10, because we have 10 stocks in our stock universe. So capital K is equal with 10. So once we have defined capital K, we can define our P matrix, capital P matrix, where we store our results now as zeros, capital K, comma 2. If we do not have defined K before, we could simply write here 10, comma 2, which would give us the same matrix of 0 entries. Yeah? But since we have defined it now before the for loop, we can just write P, capital P is equal with zeros, K and 2. And again, what we get here now, we create a matrix consisting of zeros, which has 10 rows and 2 columns of zeros. Yeah? And what we do is now, what we want to do is we want to store the alpha and the beta of each of our stock. Yeah? So what we do is we do an OLS regression of this form. yi is equal with alpha I plus beta I, which is the sensitivity against the market factor, and alpha I is the abnormal return of stock I, times xt plus ut. So that's the regression, and we do it capital K times. We get, for each single regression, we get the corresponding estimates for our stocks. We get the alpha hat and the beta hat I, and we store it in that matrix P. That's what we want to do. So now we define a for loop. So first we have to obviously create the matrix where we store in our results. Then we continue with the for loop. Now for what? For I, that's our running index, and we do not need to define because we define it now. I is equal from 1 to k colon. So we do something now from I is equal to 1 until k. So 10 times, obviously, from 1 to 10, because k is 10, and we have 10 stocks in our sample. What do we do? Okay, so we say B is what? It is X. So, okay, before we can run a loop, let us define our X matrix. So we have our small x here. This is our vector of excess returns from the market vector, and our X matrix capital X consists of ones in the first column, and this vector here X is obviously the second column. Yeah? So it's a t by 2 vector, t by 2 matrix. Yeah? And we define this in MATLAB. We have to define it obviously before we start with the for loop. So we have to define it here after we have defined p, or before, it doesn't matter. Let's define it after we have defined p. Capital X is equal with this parenthesis here, open, okay? Once parenthesis open, capital T by 1, and this x vector here, and then parenthesis closed. Yeah? So that's how we define our capital X matrix. Yeah? This bracket's open here, a vector of 1s that has the dimension capital T comma 1, then we leave a space here, and then we put in our small x, yeah, which we have already defined in the system. Then we close the parentheses here again, yeah? And that's basically now defined in our system. So we have defined our X matrix, and we have to do it before. There are also other ways to do it. We can also basically define it in the for loop. This is a little bit, yeah, it's a matter of taste. So, well, because the X matrix is always the same for all of our stocks, yeah? So we can just write now a well-known formula, yeah? X transposed, which is now this guy here, the X matrix, star itself, then we write this guy here. This guy here means take what is here to the power of something, to the power of -1. Now we have to take this away here, but we know what we do now, so we can take this away. To the power of -1, then again the star, X transposed, star, Y, and Y should be colon, double point, comma, I, colon. So what happens here? So this is our well-known formula for the OLS, yeah, our X transposed X inverted, X transposed Y. And what it gives us is our beta hat, our point estimates. Yeah? The point estimate alpha and beta hat, and which are stored in a 2 by 1 vector. Yeah? Because we have in our model only 2 parameter estimates. So what is B here? What comes out is a 2 by 1 vector, yeah? Which looks like this. Now we want to store it in P, and P is, as we know, it is a matrix of zeros, yeah, which has the dimension T by 10 by 2. So we want to store now this vector here, yeah. The alpha should be the first element in the first column. Here is the alpha that we want to store, and the second element should be the beta hat that we want to store. Yeah. So what we have to do is, so next step is we want to store in Pi, comma, double point, this guy here transposed, and then again colon. That's what we want to do. We want to transpose this guy, and we put it in P where, well, we are still at I is 1 and both columns. Yeah? And it must be like that, so the dimension must be congruent. This guy transposed is 1 by 2, and this here is 1 by 2. That's the same dimension. So we store something that is 1 by 2 in something that has a dimension 1 by 2. So the dimension must always be congruent, otherwise we would get an error message. So we end this loop here. If we have a for loop here, we have to end it as well. Yeah? It starts somewhere and it ends somewhere, and here it ends. And colon. So this simple operation, simple application of a for loop, what are we doing? So if I is equal to 1, it starts at I is equal to 1. Yeah? When I is equal to 1, it grabs the first vector of excess returns of stock I, of the first stock, and puts it here. Yeah? We multiply in our OLS formula, yeah, our data matrix of our regressor matrix that we have determined before the for loop, yeah, as a vector, as a matrix consisting of ones in the first column and of our excess returns in the second column. Yeah. So we do that using our OLS formula, get the point estimates, yeah, and store them. We transpose this vector. This 2 by 1 vector becomes a 1 by 2 vector. We store it here, yeah, in our P matrix that has zeros. And now, after the first iteration, here are entries, here are numbers, the point estimates, right? So then it goes to the next iteration. Yeah? Then it jumps to I is equal to 2. Yeah? What does it do then? Again, we have our OLS formula. We overwrite this guy now. Yeah? Obviously, you see B has no index here. So the iteration is we overwrite it. Again, we grab the second vector of excess returns of our second stock in our stock universe. Yeah? And we use our OLS formula again, yeah, getting the point estimates, yeah, using this formula here, yeah, translated into MATLAB language. We get the point estimates, the corresponding point estimates, the alpha and the beta. We store it. First we transpose it, then we store it here in our P matrix in the second row. Yeah. Here's I1, here's I2, and so on. Here's IK. Yeah. And the last iteration, yeah, when I is equal to K, when I is 10, because K is 10, as we see here, we have defined it as 10. What we do, we take the last stock, we regress the excess returns of the last stock on our regressor matrix, our X matrix, using this OLS formula translated into